Hello, this is Dahoon from Line Plus UIT team presenting about how we built the Sentry on-premise. First, I would like to explain why Line came to use Sentry and why it was built in on-premise instead of on the cloud. And finally, I would like to tell you of how we built it on-premise. First, let me tell you about the reason. The error log collection platform used in the company was not friendly to the front end. The screen you see right now is one of those examples. This error is caused by accessing a property called a feature ID from an undefined value in the release environment. The source code is compressed and obfuscated, so it's not very easy to find exactly where the error occurred in the source. So we found a platform that could be useful in the front end called Sentry. There are many advantages of Sentry, but there are two main functions. First of all, by linking the source map, you know in detail where the error occurred in the source code, even in the release environment. It also provides breadcrumbs function. You can see what the user is doing, such as a UI click or an AJAX request, to see if the error occurred. Therefore, when a request for improvement is received from users, we decided to use Sentry because we can easily check using the functions described above and further find and improve bugs in advance. Then, I would like to tell you about why we started using Sentry on-premise. Sentry is largely divided into a subscription type cloud version and an install type on-premise version. Cloud provides infrastructure and solutions at once, so developers can use it very comfortably. It also has the advantage of not having to worry about maintenance and operation. Nevertheless, let me explain why we decided to use the on-premise approach. First, we can prevent sensitive information related to the project from being exposed. Sentry should upload the source map to the server to easily check the code. If you use the cloud at this time, then there's a risk that the code inside the company may be exposed. And there is a possibility that the password to the DB, the encryption key of an algorithm, or a security vulnerability that the developer did not expect may be exposed. However, if you choose on-premise, it will be more secure than the cloud because it uses the internal infrastructure to manage source code and corporate assets. And if you use the cloud, you pay according to your usage. The picture that you see is the Sentry fee pricing plan. This amount includes such as infrastructure, operation, and maintenance. In addition, the amount to be paid varies depending on the plan, which becomes more expensive if you go to team or business. Even enterprise is not priced, and it can only be used by a separate contract. However, if you use it as on-premise, you can save much money because you only need to build the infrastructure without adding additional costs. The advantages introduced above are the reasons why we chose on-premise. Next, I would like to explain how our team built Sentry on-premise. We built Sentry on-premise in 4 stages. First, we reviewed the existing infrastructure, identified its problems, and improved that infrastructure. And after that, I measured the performance when constructing and calculating the spec and the number of each necessary equipment. And based on this data, the infrastructure was built, and finally, a monitoring system was added to monitor each device's functionality. First, we reviewed the existing infrastructure. As you can see here, the web, Walker, and DB container were all together in the Docker image. If the containers are attached together like this, scale out is impossible. Only scale up is possible. So we couldn't respond quickly when we exceeded our expected number of requests. To solve this problem, each container is separated and changed to a new structure so that it can be scaled out as it is shown in this picture. However, the DB was designed considering only scale up, and let me tell you why. Sentry is using PostgreSQL as its DB, and since PostgreSQL open source does not provide sharding, horizontal scaling is impossible. Instead, if you use a separate extension, you can use sharding, but it's not easy to use because you have to pay additional costs and also need to verify stability. So the DB considered only scale up, and replication was configured in a master-slave structure to prepare for failure. So Nginx, Web Worker have been restructured to allow scale out to accommodate more requests. Now you can increase or decrease the number of these equipment to suit your requests. And at this time, the following problems arose. How do we upgrade the server spec when the traffic increases in the future? We measured the performance of each node in the Sentry infrastructure to find the answer to this question. The performance measurement tool was developed in-house, and we used ngrinder, which is provided as an open source. This was used to determine the acceptable TPS of each device. And in order to measure the performance, I had to decide what should be the target. For this, we drew a sequence diagram of the Sentry and checked the process when the event came in. Redis used the one provided in the in-house infrastructure, so it was excluded from the performance measurement section. So we chose the Web, Worker, and DB as the targets for performance measurement. The Web, DB, Worker were measured differently. Web and DB gradually increased the number of virtual users and measured the CPU usage and load average when the number of requests increased. And we increased the number of CPU cores together to find out the relationship between the number of cores and the TPS. And the Worker changed the TPS and number of CPU cores to check the TPS at the point where the job started to accumulate in the event queue. As a result, we were able to derive a chart like this. At this time, the slope increased sharply from 8-core CPU. And starting from 8-core CPU, both Web, Worker, DB increased almost linearly. So the number of CPU cores of the node is set to 8, and the scale out is done increasing or decreasing the number of this node during scale out. So based on this performance analysis data, we improved the infrastructure. Using the information obtained earlier, we decided the performance and number of Nginx web workers that fit the target at TPS and calculated the DB node performance and applied it. When the amount of event inflow of the sentries fluctuates, this data is used to respond. Finally, we built a monitoring system. One of the disadvantages of a cloud version is that it's difficult to determine the state of an equipment because the infrastructure is managed externally. However, with on-premise, you can check this by selecting a monitoring tool that suits you. Amongst them, we built a monitoring system called using Grafana and Prometheus. We added hardware status indicators such as CPU, memory usage, and disk usage, and visualized them for monitoring. In addition, it is set to observe the status of requests and responses, detect any abnormalities, and send alert notifications via line. And thanks to this, it was effective to prevent any errors. Now I want to summarize what I've been talking about. Finally, let's summarize the advantages of on-premise. On-premise has several advantages compared to cloud. First of all, it is more secure than cloud because it does not upload the source map or other resources to an outside source. And excluding the initial construction cost, only the infrastructure maintenance cost is incurred, so the cost is reduced. And finally, you can check the internal state of the infrastructure to gain visibility. And because of these advantages, we built Sentry on-premise and have been using it in a total of 34 projects to date. I hope my presentation was very useful and insightful for you. Thank you very much.